So today we're going to be talking about proving triangles similar. Now earlier in the year we talked about proving triangles congruent, and this is along the same lines. I'm going to give you some theorems and postulates for how to prove that two triangles are similar. So you'll notice that we have three rows here. Each one of these represents a way that we prove that two triangles are similar. The first one, you'll notice that we know that one pair of corresponding angles are congruent, and then another pair of corresponding angles are congruent. Now, once you think about triangles, they add up to be 180 degrees. So, if you know that two pairs of corresponding angles are congruent, you can assume and know that the third angle is congruent as well. But we don't have to know that. That is implied. Okay, so this is called the angle-angle postulate. If you know that two angles, or that two pairs of corresponding angles are congruent, then the two triangles have to be similar. All right, moving down to the next one, you should recognize this one. Now, I'm using tick marks, but in this case, we're not talking about the numbers being congruent, okay? So we're not talking about congruence, we're talking about proportion. We're talking about how these sides are changing in a proportion. Sides change in proportion. So if we were to put a length to this, we could say that this one was 1 and this one was 2. So that means that if this one was 3, this one would be 6. So if we knew this, if you knew that two sides were proportional and the included angles were congruent, you could use the side angle side theorem to prove that the two triangles are similar. Now again, this is the side theorem. Again, we're not talking about the sides being congruent. We're talking about them being proportional, okay? So, if this is 1, this is 2, okay? If this is 2, this is 4. If this is 3, this is 6. It's all about the sides changing in proportion. So, let's look at a couple of examples. So, are they similar? Look at the first set right here. You know that you have information about all three sides, but you can't look at it like we could with congruence and say, oh, they're congruent by side, 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 or they're similar by side, side, side. What we have to do is we have to actually check to see if there is a scale factor. So I'm going to do 12 divided by 9. I know that's a corresponding side. So 12 divided by 9 is 1.3, and then I'm going to do 8 divided by 6, which is 1.3. That means that, yes, they do have a scale factor, so they are similar by side, side, side. All right, let's look at the next one. Got to find my corresponding sides. This is the long side, this is the long side, so 10 over 8, and then 6 and 6. They have to be the same if I divide them. I don't even have to calculate this one. It is very obvious that 6 divided by 6 is 1, and 10 divided by 8 is not going to be 1. So the answer to this one is a resounding no. They are not similar. And finally, the last one. So we have enough information here. You look at it and you say, okay, well, I know that two angles in this triangle are 70 and 50. I know that two angles in this one are 70 and 60. Your first thought may be, oh, those can't be similar because they're not the right angles. But you can calculate what that third one is. So if this is 70 and 60, that adds up to be 130. So 180 minus 130 means that this angle measure over here is 50 degrees. Guess what this one over here is going to be? 70 plus 50 is 120, so 180 minus 120 is actually 60. Once you see this, you should be able to conclude that yes, they are similar by the angle, simile, I'm not real sure where that came from. similar by the angle postulate. Make sure you complete the questions, and I will see y'all next week.